Okay. So once you've got it on, perfect. Okay. It's just random stuff, right? Okay, let's get straight into it. So essentially in Unit 3 methods, you have three topics. First is logarithms, then you've got calculus, which two things fall under. That's your differentiation. That's really what topic 2 is. And then you've also got integrals, which is your topic 3. Okay. Jeez, so many notifications. Okay, let me just clear on my phone. All right, that should be good. Okay, let's get straight into the first topic, logarithms. So if you look at this first line here, we've got logarithms. They are the exponent or power to which a base must be raised to get a certain number. So let's say if I have e to 5, I want to raise it to a certain power. That power is going to be x. And I can get x by rearranging to logarithmic form, which means x is log 5 to base e in this equation. And as you should know, log to base e is ln. Okay. There's also these small formulas you need to know here, like with the same base, you've got x plus y. When you're adding them, you multiply. Okay. And then when you're when you're subtracting, sorry, you divide them. Okay. It's always x over y because x comes first. Okay, just remember that. Another one is if you've got log of x to n, you can drag out the power to do n times log of x, which can make algebra much easier in like a more complex question. Or another one that's important is this one here. If you've got like log x to a base you don't really know how to work with, you can change it to another base to log x over log a to be able to solve for it more easily. And then you've also got these two, a to 0 is 1, so log 1 is 0, and a to 1 is a, so log a to base a is 1. We're good with that? Perfect. Okay. So let's do a quick logarithm question. Yes, start. I want you to do this. Find the derivative of log x squared to base 2. I'll give you 2 minutes to solve for it. Okay, okay, I'll have to like scroll through because like I can't check the chat on my phone at the same time because otherwise it switches devices. Should be okay though. All right. So that's your question. You can screenshot it, but I will upload everything once this is done. Need a water break? I'm so cool with that. Checked out with that. This should be a way. Let me quickly try it now. Okay, okay, my bad. I might be on my phone. Wait, let me just. Yeah, it only works on my laptop. Yeah, it's only one device. Did you find? No. It's okay. It's okay. Right. I'll give you 1 minute to do that, and then we can check. Wow, 68 people. Who's gonna be 69? We need 69. Come on. It's alright. Just this question. I'll just have to scroll through chat. It's gonna be a bit annoying, but it's all we can work with. We have x squared to base 2. We're trying to find derivative. And once we have an answer, just let me know. I thought we derived ln, not log. Exactly, yeah. I want you to refer back here. This would be like a harder, simple familiar question. I think we'll just go to the answer then. Sorry. If I look here, oh sorry, I have this log law here. This might come in handy where I can convert x and a to a log I can work with. So an easy one to do is just ln. So I can drag out the power first to log 2x. And then I have this part, which is ln x over ln 2. So then when I do derivative, I can easily differentiate ln x, which is just 1 over x, and I multiply that by the constant, so I get this answer. Do we get that? Yeah, nice question. I feel like they could do this just to trick with you a little bit. So I thought that would be a good way to start. Did we get that? First question. Yeah. Just something a little different. Who do we have? Okay, wow, there's a lot of people. Okay, perfect. All right, perfect. Let's go to the next thing. So next thing you need to know is log functions. They always follow this form. Fx is a log of bx plus c plus d. And they also follow an asymptotic nature. An asymptote is a line that is edged but never touched. So it approaches the line but never actually touches it. And when you look at these equations, you also have A, B, C, D. These are your typical function transformations. I haven't seen this pop up. Could be on your exam this year. So like if we have A here, that's the vertical stretch of the function. So that would make this like more skinny over here or like more fat there. B is horizontal stretch, so it could kind of come out this way. Okay, it's always a factor of 1 on B. If they put that as a complex familiar, don't forget that. And then C and D, they're just added on to X and Y specifically. So they just shift the curve up and down, left and right, so on and so forth. Another thing to notice is with log functions, you also have a domain where this part is 0. That's where the domain ends. That's something they could ask you, because obviously we can't have a log of 0 or any negative number. So I think the best thing to take from this is this part end of domain is where b x plus c is 0. It's just whatever you're logging in that function. Yeah, well, I'll put up the PowerPoint as a PDF on the help channel forum I made. So next thing, okay, so just an example of something you might want to consider is we have y is ln x, x-intercept at 1. What I can do is I put a negative sign here that flips it about the x-axis. So every y part becomes negative y. So that's why it flips here. Okay, just like that to here. And then if I put a negative over here on the x, that's going to flip it horizontally about the y-axis. So let's look at that again. Negative ln x versus negative ln of negative x. It flips it around again. Okay, just something you should know where you might have to consider the nature of a log curve for a hard question. Okay, the next thing is how logs actually work. If I have a logged number and I want to add 1, that's going to produce a result that is n times larger. It doesn't increase by just this plus 1, it increases by multiples of the base. Okay, so that's how logarithmic scale works. Like, let's say if I have like a pH, which is pretty much this, just x is how much hydrogen ions there are. If I want to add 1 to this pH, that means the hydrogen ions is going to be 10 times more with this base of 10. Okay, so that's how the scale works. All right.
People are asking if we're gonna get access to this PowerPoint.
Yeah, I'll put it up on the help channel here. I'll just show. I made. Where is it? Wow, there's a lot of questions. Yeah, it's just over here. Okay. Do we all see that? Perfect. Difference must have just. Yeah, it's fine. So that's how logarithmic scale works. Again, adding 1 multiplies by the base. Now let's do another question, because we can never revise enough. I want you to have a go at this. So we have a major earthquake, magnitude 8.1, is 150 times more intense than a minor earthquake. We're given the Richter scale, and I want you to find the magnitude of the minor earthquake to 1 decimal place. Have a go. I'll give you 3 minutes. Once I have 2 correct answers on the chat, I'll show it. Okay. Jeez, I'm already parched. Just give you guys a minute. Oh, that's bad. That's bad. All right, do we have an answer? Okay, Felix has got it. Let's see if anyone else can get that answer. If not, we can go straight to the explanation. 5.9. Okay, perfect. You forgot that's what we're here for. That's what I'm here to do, to help you remember. Okay. I know you had bi today, but look, hey, look, no more science ever again. Isn't that amazing? You don't have to do that unless you're doing it in uni. Now it's just maths for this week. All right. So here I've got the answer. Okay. So firstly, I know the intensity of this one. The major one is 8.1. I can rearrange to get the intensity of that using I naught because I have to put that here. Then I know that the major one is 1 over 150 times I, 150 times less intense, so I just substitute that here. And then I can do the magnitude just using this formula given, which is just 1 over 150 times I major over I naught, and that gives me this number, which gives me 5.9. So this is a pretty decent, complex, familiar question. So do we all get that? Oh, you copied Felix. That's okay. Didn't finish writing it. Okay, yeah. I'll give you guys a minute. You will be able to look at this later, so don't worry. Can't we solve in? Yeah, it is tech active. I'll tell you that before, don't worry. Okay, we should be fine now. If I can move on. You can always redo this question. How's it 1 over 150? Because the major one is 150 times more intense than the minor one. And the minor one's just going to be I over 150, I major. Okay? So that should be clear. All right. It's so annoying having to scroll through both. I mean, okay, just tell me when you're good to go. So then I've arranged for I, I've got I minor relating to I major, and then I've just substituted it to get 5.9. Pretty easy, very easy question actually. How do I was one? No, I is just I. I might just be the notation, but we can rearrange it using this equation. There are different approaches to it, but as long as you get here. But this does show the logarithmic scale because if I go from 10 to 8.1 over 150, if I notice 5.9 to 8.1 is not just like a 2.2 more, it's 150 times more, which shows how the logarithmic scale works. That's why I put up this question. 5 marks. Yeah, it's an internal question. It's overinflated. I think we can move on to the next thing. Let's move on. So the next thing is, that's pretty much topic 1 summarized very quickly. So topic 2 is about calculus. Calculus is anything with change. So change and the rate of change, and you've got all these formulas to show how things are changing over time. That's essentially what it is. So you know the simple derivatives like power rule, quotient rule, which come from the limit definition here. This is what you learnt in year 11. I just put it there to remind you. Okay. If they ask, so perhaps if we were to estimate with a limit definition, we could just put like smaller and smaller values of h with this, by the way, x plus h, just replace any x with x plus h. Then we do smaller and smaller values of h to approximate derivative. Okay, add an x value. So that's how we get that. And then there's also another limit you need to know, which is a to h minus 1 over h as h approaches 0, which approaches like some asymptote to graph that never has a solution at x is 0. And only if the number e produces the limit of 1. This is like something they could ask you multiple choice. Okay, yeah, limit stuff is a bit confusing, but it could be multiple choice. It was last year, probably will come up again. Perhaps they ask which produces the limit of 1. It's the number e, because e to 0 is 1. It works out. Speaking of e, you know e to x is an exponential function. That's just the inverse of log. So you'd reflect it, stuff like that. It would be about y equals x. So it would just go like that. You know how e to x looks. And the derivative is just e to a function. It's just I do e to a function and then multiply by the derivative. So that's pretty simple. First principle, no, but they could pull it somewhere. I don't know. You never know what they're going to do. Okay. So, yeah, it could be an MC. So these are derivatives that aren't on the formula sheet. If you forget the other ones, just fucking look at it. It's right in front of you. So for sine, you know, sine goes to cos, cos goes to negative sine, and then with this f of x, you just multiply by the derivative. This is chain rule, okay? And the most important one is this one here, very special derivative. If I have ln f of x, the derivative is f prime x over f of x. This was actually on a complex familiar question last year, which wouldn't require u sub. You need this specific fact, because obviously specials kids know it, but we don't. This is what we stick with, f prime x over f of x. Where the e to f of x one, I did that just over here. It's all there, trust me. Okay, so that's pretty much all you need to know. There's also your obvious ones like chain rule. So these were examples of chain rule. Okay, then you've got product rule, quotient rule, and trapezoidal rule. I've got another slide on that coming up. Firstly, let's revise products quotient rule. Just try doing these two derivatives. I'll give you 3 minutes. Okay. All right. This is so chaotic, bro. I'll give you guys another minute. Very awkward. So do a quick go. I tried loading on my phone, but it doesn't actually work. It disconnects me from my laptop to my phone, unfortunately. I know I can do it on like the normal calls, but not this one, which is weird. You know, this should be the more organized stage, but it's fine. Okay. We got that out? Yeah. Not bad. Okay, let's go through the answers then. So what I've highlighted here is what you would use for U and V. This is a U term. So I see in the first term, I just differentiate U, and then I drag U, okay? And then here I drag this term, and then differentiate this term. I just do that for product rule, and I get my answer of ln x plus 1. Then for quotient rule, I do V, okay? I've colored V in blue. So it goes by VU prime minus UV prime over V squared. So if you want to remember quotient rule, just remember it starts with V, okay? And you should get this answer here, ln x minus 1 over ln x squared. Okay, easy. Yeah, easy one. Next thing, let's do a complex unfamiliar question. Let's do something a bit more tricky. I'll give you a good amount of time for this one. What I might do, just snip it for now, so I can see the chat, like, as you guys are trying to figure it out. Okay, we'll just load it here. You're done in 7 marks. Alright, this is tech-free question, by the way. I like here, I'm vibing with this. Alright, I'll just have this open to look at it, and once, give me your answer to 2 decimal places, and then I'll check. Save to clipboard. Let me just scroll while you guys are doing that. So, oh, okay. But I mean, I'm year 12, like, you can't really expect much. I did methods last year, so that's why I'm here to help out. As much as I can, just, that closer connection for insight. So I'm obviously not as good as the uni guys, they've obviously. It's not 1.24. I don't think it is. Oh, it's not what I got. I might check. We can check our answer again. That's completely fine. It's just this one. Yeah, so non-calc, get your exact answer and then give it to 2 decimal places once you have it. I don't think I messed up my answer. Should be fine. If not, we can check it. That's completely okay. Oopsie. That's right. It's a bit tricky. It's been 2 minutes since I put it up. Okay, it's it's no worries. Let's see who's here. Okay, we got Freya. We'll give people a credit. We're not cooked. It's been 2 minutes since I put it up. So this was our question again. Complex unfamiliar. I don't think they'd ask something like this, but could be a bit more creative, like complex familiar in paper 1. This is tech-free. Yeah, once you have a tech-free answer, give it to me into 2 decimal places through your calculator, and I'll check it. I don't think my answer's wrong. It doesn't match what you guys got yet. Who is this, bro? Oh my god. Is this some cartoon? I don't remember. Okay. I did not get 7.39. Maybe it's good we go through the answer then and check if I've messed up. I should have done it properly though. Let's have a look at what I got, okay? So firstly, we have tangents in the question at these two x values. So obviously I calculated those tangents. So if you get asked to calculate a tangent, what you want to do is find the point, the f of x, and then do the gradient f prime x. So what I've done here is this is a gradient, this is a point, and then I've just substituted to get y is mx plus c. Or you could use the other form, y minus y1 is m times x minus x1. Both work, and these are the tangents I got. Do we agree? Okay, yes, I'll like that. Ooh, okay, yes. Show again. All right, got tangent 1 here. If you have a tangent, remember, we do the f of x at that point, the point, and then the gradient at that point. Okay, that's all you need to do. And then substitute into equation of a line. I'll give you another minute to look. There's a second part to this answer, by the way. Did you say huck to yes? All right. Now that we've got those two, let's look at them on a graph. Okay, this is my curve. This is the first one, x plus 2, because that's a y-intercept. And then this is e squared x, y-intercept is 0. So what I've done is I know area of triangle is base times height over 2. So the base here is 2 units. And then the height here, that's just the y value. So I can use that, find that using the intersection. E squared x is x plus 2. So what I've done here is some factorizing. And then I've got my x value and my y value. And this should be your final answer, 2 over e squared minus 1 plus 2. It's pretty weird. Solve in 1 minute. This is tech-free. I just gave you this graph to see it better. If they do ask this like harder question, they'll probably give it to you anyways. By the way, this decimal answer was, I think, 2.31. Yeah, 2.31. And you can see here that if I have like 2 and 2 here, that's like 4. So it's going to be around 2. So 2.31. I think I'm correct. How do you know base is 2? I just look at the x-intercepts. They're 2 units apart. So the base is 2. Simple. And remember, it's bounded by the x-axis. It says here. Okay? So a 2 between. Base equals 2. Substitute that here. That's base. That's my height. The y value is the height of the triangle. Again, you'll have this for later reference. This was actually from my IA2 exam last year as the last question. It was 7 out of 100, I think. 100 marks. What if you didn't have a graph? Yeah, it was my IA2. If you didn't have a graph too bad, you should be able to visualize it. Like you should know how, like sine, cos, x squared, x cubed, you should know how those look like off memory in case you need to refer to it. All right. Okay. We good with that? Have I finished methods? Yes, I did it last year. Whereas plus 2, that's just me putting it into y is x plus 2. I'm just substituting to find the y coordinate. So I get this plus 2. Simple. Okay, I'll give you another few seconds to look. How are we? Yeah, you forgot it. It's right. Back to previous slide. So again, we have the tangents here. I'll say it again as many times as you need. We find the point, okay, the reference point, and then we find the gradient at that point, and then we just substitute into equation of a line. That's all you're doing. If they ask tangent anywhere in your exam, just do that. Okay, that'll get you marks no matter what. So good with that? All right, yeah, perfect. You'll see this later on anyways. Okay. And then we've got the graph of base times height, which is this. Okay, let's move on. Next question is calculus again. So a lot of what we use calculus for is for finding the maximum or minimum values that change over time. So I want you to have a go at another question. I know it's a lot, but don't worry. This is good revision. So what we have here is the position of a particle as it moves horizontally is described by this equation. We have s of t with these bounds. And I know that s is the distance meters to the right of the origin, and t is time in seconds. So what it's asking is determine algebraically, so no calculator, the maximum distance to the right and to the left of the origin. Ignore the 10 marks, that's just internals being overinflated. Okay, I'll give you a while to look at it. I'll screenshot it again. So we can use derivatives to find maximum or minimum value. You'll see that a lot more like reinforced in unit 4. So you can understand that. Yeah, don't worry about it being 10 marks. This will probably be like 7. Yes, max is to the right, because look at how the question is asked. So the max would be biggest positive value, which means it's most to the right. Have a go. Cos 0 is 1, yes. Is this complex? No, this is complex familiar. It's pretty easy. A bit tedious. I'd give it like 7 marks if it was an external question. Like, this would be a good question 17. Okay. Who's that? No, right, okay. So don't do it on your calculator because you'll get the answer right away. So again, here we're using applications of calculus. Yep. Well, 56, that's very good. 57, right? You can use Desmos Symbolab personally. I love using Symbolab. It's such a good friend. Oh, you will get banned? Okay. If the mod says so, then that's not my call. Okay. It's tech free. Have a go. Big bike stop. Alright. So is this being recorded? Yes. Someone is recording. I think it was. Oh, how do I forget? I'm so sorry. I think it was Daria recording it. Yes. I'm very thankful. If you could like send it to Ollie after, that would be great. Yes, of course I remember you. Okay. Perfect. Will recording be free? Of course. It's up to Daria who's recording it. Just ask them. Okay. I can't lie, I forgot how to do this. That's okay. That's what we're here for. Okay, you've got tonight and then 3 more nights to your exam. You'll do well. Put on G Drive, ask Ollie to upload. Perfect. Okay. Make it free. Yes, it will be free, don't worry. That's the whole point. Free masterclass. And don't forget to type in answers once you have it. I'll just vibe with the chat as I wait. Okay, good job, Panda. Okay, Panda's got it. Okay. 3 meters? No. Okay, how do I close the boiler? Okay, that fixes it. Perfect. Will you remember me? Oh, of course I will. Instant nuts. I won't forget you, don't worry. You don't need calculus yet. You can use a different approach. Dean just said instant nuts made me giggle. Bro, giving Twitch. I like it though. It's alright. Let's go through the answer then, using a calculus approach. Okay, yes, Aria, yes. I'm glad you're here, mate. Finally done more question. Okay. Dean, can you refer to us as chat? Sure. I don't know, it just feels a bit weird. Can you give us an intro? I already did that though. I'll have once someone else types up the correct answer, I'll show you. Okay. Did you make this me? That's crazy. That's fine though. Everyone like it. Okay. Oh. Oh yeah, please like it, chat. Good meme. I appreciate the effort. 22, Jesus Christ. Oh my God. You're very welcome, Mr. Chat. Is this real? Okay. Does anyone else have the answer yet? Just let me know. Otherwise, we'll just keep going along. Once you have your answer, just type it under spoiler. Okay. Bam, just like that. 2-1. Good job. Okay. So 2 people got it correct. Let's have a look now. Bro, who even is this? Okay. What is that, chat? Okay. Let's have a look now. This is a whole answer. So we know at the maximum the derivative is 0. So just ds on dt is 0. So what I've done here is a chain rule. So what I do is drag the power, subtract power, so it becomes sine to 1, and then I multiply by derivative. For the second term, I do 4 cos t times negative sine t, because that's the derivative. That cancels out this minus, so we get plus. And that gives us 6 cos t sine t 0. So I can use null factor law to solve for t. I get these 5 values within the given bounds. Okay, this one can be ignored, but whatever. So if we just test these values, we can see that these values give a 1. So that means 1 meter to the right, since it's negative. Oh, sorry, positive. 1 meter to the right, as in the question. And then if we do these, we get -2, which means 2 meters to the left. So the max distance is 2 to the left and 1 to the right. So good job, guys. Okay. Nice question. Yeah, it's from my internal again. All right, let's move on now. I think we've got that. So that pretty much concludes topic 2. Topic 3 is all about integrals. It's just the antiderivative. It's when we have a derivative and we want to go back to the continuous analog of the sum or function of those changing rates. So what actually originates from those changing rates? I'm using words just to help you. So the ones you should know is this one. This is rectangle rule. I'll explain that in a bit. Then this one, FB minus FA, that's the fundamental theorem of calculus, with just any integral in general. We also know integrals, which are areas. They can be added like this or multiplied. This actually came out in our specials external, this type of integral. Then we've got power rule, where we just add to power, divide by new power. I like this trick. In case you have like fraction powers, add to the power first, and then you divide by the new power after adding it, okay? And then you've got these basic integrals from your derivatives that you know from your from topic 2, which is also in your formula sheet. These are all included. This is from the 2025 one, by the way. I just thought it would be good to remind you guys. So we've got these two as well. Riemann sum is just rectangles, by the way. So this was a funny jump scare on last year's external. I looked at it, I was like, what the fuck is that? Because I'd never seen it before. It's really simple though. It's just we have, over here we have delta xi. That's just the width along the x-axis of I, of the ith point. We have delta xi width over here. And then f of xi is just the y value, and that makes, obviously, a width and a length for a rectangle. And we can just do multiple of these to estimate this integral from 2 to 6, as you can see here. Then you've also got trapezoidal rule. The tip I like to remember is area is a W, the width of each strip, by the way, over 2. And then in the brackets, you add the endpoints and multiply all the middle points. You add them and multiply by 2. So W over 2 times endpoint plus 2 middle points. Okay. Another thing to mention is concavity. This was in our assignment, my assignment, is that I know this part is concave down. So over here, so what I see is that the trapezoid, you can see it kind of tacks on to the curve like that, which leaves this gap here. So that's an underestimation. If it's concave down, then this rule will underestimate the area. Whereas if it's concave up over here, you can see it's adding a bit extra. That's an overestimation, just another tip. So concave up, this will overestimate, and concave down, this will underestimate. So is that good? Yes, there's also left rule, right rule, but you'll have the specific values to use. It's completely acceptable both
Sorry,
ways. Yeah,
DN. I'm just wondering, are we able to use spec rules and spec like U sub in our integration?
I would suggest not to, because
No.
you don't need to. It's just forget specials now. It's done.
Okay.
The trauma's
Okay.
over. Yeah. All you
Got you.
need, only specials thing is really U sub, but that's just the f prime x over f of x for the ln derivative. So yeah, that's one thing I do have I mentioned sooner than later. So over here. So integrals not on your formula sheet is if I have, let's say, sine of ax plus b, I have a derivative over here of a, so I have to divide by that to get negative 1 over a cos ax plus b plus c. This function here stays the same regardless. And same thing for cos. There's also this one here that I should mention. Again, this is just power rule. Add to power, divide by new power. But we also have the a here. So I have to divide by a, okay? And plus c. Don't forget your plus c. For this one, obviously, we can't have n equals negative 1, because if we do negative 1, then we have 0 here. This does not exist. So if that happens, we have this form, which gives us the ln, because f prime, this is f prime x over f of x. If you look at it, if this is f of x, then f prime x is a, but I have 1, so I must divide by a in my answer. Here I've put absolute value, which is how a specials kid would write it. You can just use the normal brackets, it's fine, but this helps remind us that we always do logs of the absolute value, of a positive value. It's never going to be 0 or negative. So that's why I've just written that again. But you can just write the curvy brackets here for ln, and you're completely fine. Okay. There's people that don't. Yeah, you should be fine. It doesn't, the notation, just stick with the round brackets. Yeah. Yeah, they won't care. They'll account for it. Next thing, this is a final thing of today's lesson, is this final question. This was this was called a complex unfamiliar on my I2. I know, amazing, but just have a go, and then I'll get to the answer. So we have x equals k, it divides the area under this curve over this domain, I'll explain that in Unit 4 lesson, into two regions of equal area. And obviously it just says here to find the value of k and justify, evaluate the reasonableness to, because that's how they wanted to test us. Just find the value of k and we will conclude there. I hope my voice is not too parched, by the way. I'm talking a lot. So it does dry my throat a bit, but should be fine. Got water in my hand. Okay, let me just screenshot this again. This is our final question for today. And then we're completely done with Unit 3. Oh, how do you... Dean, are you him? No, I'm not him, unfortunately. Get out. Speak up. I'm just play this on stream. Is it a video? I don't know if I should. Guys, should I? Again, just type the answer once you're done. Okay, that's all I'm waiting for. Okay, play. If the mod says I can, then I'm fine. Okay. Give a like. That deserves a like. Okay, bro. Let's blast it again. Where is it? Alright, do we get that? Cuts off, yeah. Can you go through a trapezoidal question? Sure, I can do that. Alright, chat. Are we finished, chat? We hear your mic picking. Yeah. Okay, so one person's got it. Let's have a look. Firstly, we have the area. I've given a beautiful little sketch. So we have cos 2x from 0 to pi on 4. This is an x-intercept. They were nice with the question. Obviously, we want the total area first, which is half, if you do that. So we know the integral between 0 and k is 1 over 4. Okay, so we solve this integral, we get half of sine 2x between 0 and k. So I get half sine 2k minus half sine 0, which is obviously 0. So I get this part is pi on 6 here, because this part is half. So sine inverse half is pi on 6. And then I get k is pi on 12. And to evaluate reasonableness, you just do this integral. You'd get 1 over 4, so the solution is reasonable. Perfect. Yeah, this was a complex unfamiliar. Am I muted? No. It's right here. But this was the second last question on my exam. Alright, well, with that being said, so for this domain, I'll just add here, if you notice the square brackets, that means I'm going between these two values exactly. So I'm touching 0 and I'm touching pi on 4, and I'll touch mentality later. So we have x equals k again. That's just the area over here. I know it looks weird, but this is actually the same area here. I know, crazy. Okay. Yeah, this one's complex unfamiliar. Okay. So do we all understand? Just solve for this integral. This could be a simple familiar, honestly, if it comes up on your exam. But yeah, 8 marks, I'd give it 5. Just solving for k probably 4 marks. Okay. How do we know k and 0 is the exact number? Because once Okay. Unit is a minor. Okay. So do we so what was our question again? How do we know k0 is the exact number? Because we're integrating from 0 to k. That's all we're doing. Okay? It's in the boundaries where that's given to us in the question. So I would suggest if you have a calculator, or if you can visualize, it's very good to visualize, just try to draw a graph because integrals are always about area. So this area here is the same as this one here. It doesn't look like it, but it is, surprisingly. Yep. That is definitely. So next question, please. Well, that is all I've got to cover for Unit 3 today. That's actually all there is. You don't really need to know anything else. So I'm very grateful for all of you attending this class. It was a very quick, we got through it in like, what, 58 minutes? So now what we'll do is I'll put this up after we're done, and we can do some just simple questions after this. Yes, Unit 3 is very easy. I'll warn you, my Unit 4 one has a lot more content. I'll probably do it on Wednesday after the lit external, just because our mentality's doing it. I don't want to stress him enough, Yeah, because, yeah.